Welcome back. In this video, we're going to continue talking about standard form of quadratics. So we're going to begin with a little review. Okay, I want to review graphing with you, just again to make sure it's staying fresh in your minds. So, little graphing review for you. So remember, A is going to be -2, B is -4, C is 1. So when we want to go and graph this, the vertex is -b over 2a. So the opposite of -4 is +4, and 2 times a is going to give us -4. So the x value of our vertex is -1. Now we're going to take that -1. We want the y value of our vertex. So we're going to take that and we're going to plug it in. All right, now here's very important to think order of operations. So here, order of operations says a square first. So -1 squared is a +1. +1 times -2 puts it back to -2. -4 times -1 is a +4 plus 1. -2 plus 4 plus 1 is going to be a +3. So I plot -1, 3. Now axis of symmetry, remember, is that vertical line going through the vertex. And you always take the x value to find it. So x equals -1. And it's important because now we need to find our y-intercept. And here our y-intercept is at 1. And so now I reflect it. It's 1 away, so I go 1 on the other side. And that gives me my curve. And really quick check. It makes sense that I'm going downward because notice that -2 out front. So it makes sense that it's going to be facing down. So it's little tricks like that that you can use to make sure that you're doing these right, that it's facing the right direction. Now let's focus on the rest of the vocab. So notice it is on top. It is the maximum value, and the maximum value is up at 3. Domain, we love domain. It is all real numbers. And then the range, we're looking back at that 3 that we're starting up top. And then we notice everything is going down from it, okay, underneath. So that y is going to be everything less than or equal to that 3. So that's a little review on graphing these things. Now today the focus isn't graphing anymore, okay? But it is important because that idea of how to find the vertex is critical for today. Because of the word problems that we're talking about are where we're asking for the max or the minimum value. And as you know, that occurs at the vertex. So being able to find that vertex is critical. And then plugging it back in to find out what that maximum or minimum value actually is. Okay, so let's see what I'm talking about. So our first example, the height of a ball thrown upward from 5 feet with an initial velocity of 60 feet per second can be modeled by h of t is -16t squared plus 16t plus 5. When does it reach the maximum height? So the when is that x value where we need -b over 2a. That is when the maximum occurs. So here's a, b, and c. So -b, so -60 over 2 times a. So -60 divided by -32 gives me 1.875 seconds. Now, if your calculator shows you like the ending value, so you can see there's 3 decimals here, I want you to write all 3 decimals, okay? That's going to be important. So show me all of those decimals when you're answering these. Now, remember here, what is the maximum height? So the what here for that maximum height is where you plug it back in, all right? So negative 16 times 1.875 squared plus 60 times 1.875 plus 5. And if you type that all into the calculator, okay, if you type that all in well, you can just hit enter, okay? Again, if you type it in exactly the way that I have it written, then you can actually just type that in, and it should spit out 61.25 feet, okay? But again, only if you type it in exactly as I have it. So this would be a great opportunity. Have a calculator in front of you. Make sure you can type it in and get that same answer, okay? If you're not getting the same answer, then it means you're doing something wrong. If you are, awesome. It means you're typing it in right. So here is how long it takes, and here is where the vertex, how high it goes. So let's think here. When is the ball going to be 5 feet from hitting the ground? Well, if you think about it, it started 5 feet above. So it started 5 feet above, and we want to know, when is it going to hit that 5-foot mark again? So what I want you to picture when you get asked questions like this, when it's going to be back to that same height? Well, you know this distance is 1.875 to the vertex. Well, isn't the rest of the way, because you're going back to that same height, isn't the rest of the way just twice that? It's another 1.875. So if I do that, I get 3.75 seconds. So sometimes it'll ask you to do that. How long will it take to return back to that initial height? Well, all you have to do is double the time it took you to get to the vertex, because it's symmetric. So it'll take you the same amount of time to go back down. So let's try another one. So when does it reach its height? Well, here's my function. So the when is that x value, that negative b over 2a. All right? So negative 50 over 2 times negative 16. So negative 50 divided by negative 32. 1.5625 seconds. Again, keep all of those decimals for me, please. So now that we know when it reaches it, now we want to know what is the maximum. So now I'm going to plug it back in. And if you type it in, just as I have it written here, into your calculator, which is giving me, just one moment, it's giving me 40.0625 feet. If you type it in exactly as I have written there, it'll just spit out the answer for you. So again, this is a great opportunity. Make sure you are getting that value. If you're not, ask me in class. I can help you get there. And when will it be 7 feet from hitting the ground? Well, this is that same idea as before, where if you're going back to the same height, that you started at, it's going to be just twice the distance to the vertex. Twice the time that it took, because it takes that time to get up to the vertex, that same amount of time to get back down from the vertex. So if you multiply that by 2, it will take you 3.125 seconds. All right, so now there are other examples out there. So here's an economics example. A model for a company's revenue from selling a software package is R, which is the revenue, equals negative 2.5 p squared plus 500 p, where p is the price in dollars of the software. What price will maximize revenue, and what is the maximum revenue? Now here, what you might notice is you only have 2 terms. That third term is missing. So I would think of that as plus 0 at the end, because then I think it's easier for you to remember. Here's your A, here's your B, your C just happens to be 0. Okay? So, what price will maximize the revenue? Well, that's going to be that negative B over 2A. So negative 500 divided by 2 times negative 2.5. So negative 500 divided by negative 5. So it's saying $100 is going to maximize their revenue. If they set the price to be $100, that's when they're going to make the most money, according to supply and demand. How much money are they going to make? Well, let's find out. I'm going to plug in that 100 now. So negative 2.5 times 100 squared plus 500 times 100. That company is going to make $25,000 of revenue by using that price. Okay, that's going to be the maximum that they can. All right. The equation for the motion of a projectile fired straight up at an initial velocity of 64 feet per second is h of t equals negative 16t squared plus 64t, where h is the height, t is the time in seconds. By the time the projectile needs to reach its maximum point, how high will it go? So again, that how high will it go? That maximum height means vertex. Negative b over 2a. Again, to avoid confusion, think of a plus 0 at the end. If it's missing that last term, it's just plus 0. So then you can more easily see our A, B, and C. So negative B is going to be negative 64, 2 times A. So negative 64 divided by negative 32 gives me 2. So it takes 2 seconds to get up to its maximum height. All right, and then how high is it going to go? That's where you plug that 2 in. And again, if you carefully type it in, just as I have it written, you should get, it goes 64 feet in the air. That's going to be its maximum height before it turns around and starts coming back down. All right, thank you for joining me for these videos. So, again, please make sure you summarize what's happening here. There's a lot of good stuff, but it's easy to misinterpret it with all the other stuff that we're learning. So make sure that you write a summary. Write down how are you going to remember this? How are you going to keep this straight compared to everything else I'm asking you to do? And then come back ready to do your practice work.